So today agenda will take introduction to the other transformations. Select transformation, derived column transformation, lookup transformation, and join transformation. See, already in data flows, you have seen some 4 transformations, I think. So in data flows, already you have seen about source, where you can configure multiple input sources, and at the same time sync transformation. And you know the difference between copy activity and source and sync transformations. So between them, between these two things, that you can perform different transformations. And you have seen about union. The default behavior of union is not allowing duplicates. Okay, at the time of loading into the table, if any record is duplicated, the duplicated record will be eliminated. You just check in the practical. Suppose some cases, if you don't want the duplicates, means, for example, I have file 1, I have file 2. Think that schema is same. I want to load into a table. Let's say table 1. What I want is I want duplicates. Any idea? Ceci?
Actually, what I have observed is the union is allowing duplicates, sir. From file 1 and file 2, it is allowing duplicates. And if we don't want duplicates, we need to use group by.
Yeah. Actually, that depends on the target table properties also.
Yeah.
Okay. Depends on target table, which table, target table that you are loading, depends on that one. Depends on the properties of that, that means attributes of the table, constants of the table, the union will be behaving. For example, a simple case like a file 1, file 2. So as it is that I want to perform that one, I want to merge the things, and I want duplicates as it is. You don't want to perform any other kind of activities. In this case, don't perform the union transfer. Don't apply the union transformation into the table 1. A simple solution, data flow 1, which is doing only file 1 to table 1. And data flow 2, create a separate data flow, which is file 2 to table 2. So because the union is causing some processing time. So instead of doing that, simply if you do a load like this, whenever you don't want duplicates, whenever you want duplicates, okay, data flow 1, separate data flow 2, separate data flow. Run these data flows within a single pipeline or separate pipelines, that is your wish. So in this case, there is no additional process called union, so that processing time will be reduced for you. So you have to go with the union. You have to go with the union whenever you don't want duplicates. So then only go for the union transformation. If you want duplicates, no need to go for the union transformation. Straight away, just load it like this. Okay. And also after union, you have seen one more transformation. What is that? Exists. Here you have two things. One is if you want the intersection, go for exists. And within the exists, there is other option, does not exist. That means exclusively for left side data set. That means exclusive records for left side data set. Already we have seen in our last example, we have seen with this one. Today we are going to take overview. Already practical part already we have seen about above 4. I come to the next level transformations, which is select. Actually, in case of SQL, you have a select statement. But here the select transformation not able to perform complete operations of SQL select. Only limited operations that it can perform. One is rename the columns. And second thing is drop some unnecessary columns. And third thing is reorder columns. Of your source table. So for these 3 lines, the single statement of source data set you can say. See, first of all, why you need to rename the column? Why you need to rename the column? Especially these renaming the columns will be used in the phase of mapping the data flows. See, in mapping the data flows, the target table is having a different column, source table is having a different column, but purpose is same. Okay. Now in this moment, if auto mapping is enabled, the data loading will be failed into while inserting data into the proper associated columns. That's why, as per the expectation of the target table, you have to rename some source table columns. A small example here in the source, you have ID and name. In sync, I have employee code and employee name. Now, in this case, what you have to rename? So from source, what you have to do is using select column, ID as e-code and name as e-name. So this is what is the meaning of the first column, rename the columns. Okay. And second one is drop the columns. Whenever some data is trying to be loaded into the target, your ADF data flows are trying to push all the data into the target table, but target table is not having all the columns. Again, same example. In the source, I have ID, name, salary. But in the sync, I have only ID and name. In this case, I need not to rename anything. You have to drop the column at the time of loading. You have to drop the column salary. Okay. Then ID to ID, name to name, automatic mapping will happen. Salary column that you have dropped. If any column is in with a different name, then so you have to first rename the columns and then drop unnecessary columns. That is the meaning of second statement. And reorder the columns. The third one is reorder the columns. This is also responsibility of select transformation. So in case of reorder the columns, the source is having ID, name, department number, and salary, and then gender. But my target, which is sync, is with ID, name, gender, salary, and department number. Now in this case, you have to reorder the source as the same order as the sync. You have to reorder, not rename. Columns of source as same order as target. So this is one thing. One use case at the time, because auto column there is auto mapping, but auto mapping always not work out, sir. Whenever you have enabled mapping data flows, that means manual mapping, you have to perform such kind of things. And one more thing, you have to join two data sets, or you have to merge two data sets. I'm going to apply unions on a data sets. For example, union of source 1 and source 2. I want to join. I want to join into the target. That will be a sync 1. But sync 1 schema different. Sync 1. This is following order A. Sync 2. Sorry, not sync 1, source 1. Source 1 is following different order. Source 2 is following different order. But columns same, but order is different. You want to apply union, then reorder any one of the source. It's same as second source. For example, here ID name. Here name gamma ID. Maybe other column is there. Some column you want to drop, some column you want to rename. But finally, these two should be in the same order. At that time, you have to perform the operation called reorder the columns. These three activities will be done by using this select transformation. But what is the limitation of this select transformation? Is you cannot generate any new fields. The limitation, you cannot generate new fields. Okay. So to generate new fields, you have other transformation. That is a derived column transformation. Derived column. The transformation name itself, derived column. So at what situations that you have to generate a new fields? Ceci, please example. A small, I have a source. Source is SQL table, which is EMP. It may be file or table, whatever it may be. The schema already I have ID, name, salary, gender, department number. These are the columns I am having. So this data I want to load into the target. But in the input table, I have only 5 columns. But my target table may have different columns. The transformed EMP is my target table. My target table is expecting ID, name, salary. Along with that, I'm expecting tax. After that, HRA. After that, net salary. And then gender. And then department number. And then department name. For example, the task is like this. From the input, for salary, I want to apply some 10% of the 10% of salary as tax. Okay. And at the same time, some 20% of salary as HRA. Net means the salary plus HRA minus the tax, some expression. And next, I want to generate one more field called department name, but actually in the input field, there is no department name. Only I have department numbers. The two for the department number, I want to do some conditional transformation like 11 as marketing. If department is 12, that is as HR. If department is 13, that is as finance. Okay. 11, 12, 13. Suppose other than 11, 12, 13 and remaining all the things as others. I want to perform this transformation. Input table has only 5 columns. Output table is having 9 columns. Additionally, the tax, HRA, net, and everything you have to generate. In runtime, while loading data only to perform these transformations, you have to use derived column transformations in our data flows. All of you understood about it? The difference between select and derived column, what is the difference? Sanil, Rajesh.
We cannot add new columns in select.
Yeah, we cannot generate new columns definitely in the select, but in derived, we can generate. But the thing is what is the use case of combination of select and derived columns? Already you know the limitation. Select cannot generate. Derived column cannot do what select is doing again. Okay. Now in this case, consider the same example of above. This is the case. First I go with source. My data flow is df1. In my data flow, first I am taking source. For the source, I am applying derived column. In derived column, I will generate new fields. Okay, I will generate new fields. After that, for the output stream of derived column, I will apply select transformation. I will apply select transformation. Whatever the fields I don't want, I will drop them. If there is any field with a different name, I will rename it. At the same time, I will reorder all these things as per expectation of my sync. Finally, I will load into the sync. In this way, combination of derived column and select that you can use. Okay, this is exactly the main difference between copy activity and data photo in data flow, the source and sync transformations. Between them, you could able to perform different other transformations. Okay, this is what your second transformation. And one more important transformation that regularly what we are using is the lookup transformation. See, sir, in case of especially in ADF, you have two lookups. What are those? One is lookup activity. Second is lookup transformation. The name is same, but purpose is different. Lookup activity is reading all data of a file in JSON format. Better say data set, not file, data set in JSON format. Okay, but lookup transformation in data flow, the purpose is different. What is that purpose is? Purpose of this lookup transformation. To match key value. From one table to other table. So here the source or sync both can be any data set. That can be a file or that can be a target. A small example I'm going to take you. I have table 1. Suppose the table is a sales table. This is a table. table in our Azure SQL. Here the columns, the schema is like this. First, transaction ID, date of transaction, customer ID, product ID, and price, sales price, and remaining other fields. Okay, place of transaction also. In this way, some fields are there in the sales table. The sample rows of it, let's say transaction ID T1, date of transaction 2021, and 12 and 01 something. Okay, this is the date of transaction. Customer ID is C1 or C101. Product ID P1. Price 50,000. Place Hyderabad. This is the first transaction. Same thing. The second transaction is like this. On the same month, same day, but customer is different. Customer 103. Purchased product 2. Price 80,000. Location Pune. The transaction takes place location, that is. This is what our table number 1. There is other table which is in the format of key values. Okay. Let's say this table is about only customer info. Customer info is one other table. Here I have only 2 columns, that is customer ID and customer name. Only these are the 2 columns that I have. Key value. Treat that customer ID as a key. But what should be the key in the transformation model? You will be configuring that. Customer ID as a key, customer name as value. Let's say C101. He is Prashant. C102 is Sesi. C103 is Anil. C104 Rajesh. In this way, I have many number of already registered customers are there in the database. If you look at this, sales 1 table, there is only information of the customer ID, but what is that customer information that is not available? Okay. So for this, without lookup, generally in SQL databases, you can apply joins. But for this small activity, if you go to the joins, performance will be degraded because joins needs more computing power. Okay. So that's why internally, what ADF will do is the second table, which is in the format of key and value, it divides them into the key and value base. Internally, it will maintain one map object. Generally, in object-oriented programming, you have different collections, list, tuple, map. In this way, different objects will be there. The map is a collection of key and value pairs. All the data of the second table will be loaded into one map object. Whenever a key is passed, immediately the value will be retrieved from that object, from that collection object. Okay. So by using such kind of algorithms, I want to map these 2 things. This customer ID in the place of customer ID, or along with customer ID, I want to maintain his information. Suppose look at the first row. The first row transaction is made by the customer C101. Who is C101 here? Prashant is 101. Second transaction is by C103. Who is C103? That is Mr. Anil. Okay. So I want to provide complete information along with customer ID. I want to provide information of customer name also. At this moment, we need to go for lookup transformation. So what is the style of here? Here I have 2 tables, sales 1 and customer info. I will configure source one. For the source one, in the source one, I will keep sales one table. That means the data set for the sales one. And for the source two, you are going with customer info. But it should contain only key and value, sir. Only one key, one value. Always key should be unique. Value can be duplicated. Right? Okay. Now, I'm defining a data flow. The data flow name is, let's say, df1. First, source one you will drag. For this source one, you will attach a transformation called lookup. While attaching lookup, it will ask you the second source. For this, you will attach source 2. The source 2 should be in the format of key and value. Okay. Then, still, if you want to reorder the columns, or rename the columns or drop some columns, still if you want to generate new fields, if necessary, apply derived columns. If you want to generate any new fields, if you want to reorder or drop or rename the columns, apply select. Then finally map them into a sink. In this way, between source and sink, a lot of other transformations here, like lookup, derived columns, and select. Now, finally, what I am expecting is into the sink expectation. Same columns. Same columns as like this. Additionally, I want to generate new columns. After customer ID, I want customer name also. Okay. And price, place. After price, I want to generate some discount also. How much discount is applied to this particular customer. Okay. So I'm going to generate some 10% or 5% discount. So that's why like I am using derived columns here. But target table is in the different order. And that's why I will apply select transformation also to reorder the columns. But to associate, to attach customer ID along with his customer name, here I am using lookup transformation. Finally, with same order, the data will be loaded into the target table, which is the sink table. All of you understood the purpose of the sink, so not sink. Here, Rajesh has a question. In lookup, we can pull multiple columns. No, Rajesh. A small example for your question. Look back to the same table. I have two separate sources. This is one basic sales table. In customer, there is a customer info table. Customer info table. Within this, only customer ID and customer name is there. And there is a product info table. Within this product ID and product name, product description is there, or product name is there. Is it your question?
No, sir. Actually, in customer table, by using customer ID, we need to pull like 3 to 4 columns.
Okay, no. At that time, you have to go with the joins. Whenever you are coming to the lookup means, the second data set should be key and value format.
Okay.
Okay. So at the time of lookup only, it will ask you what is the lookup column. That means what will be the final joining column.
Okay.
So when customer ID is passed as key, the associated column will be retrieved as value.
Okay.
Okay. So based on your question, another different question here. What I want to generate, the target expectation is like this. The expectation, first transaction ID, date of transaction, customer ID, customer name, product ID, product name, price, okay, forget about discount, and place. These things I want. I'm expecting this answer from Sissy. For lookup, you can attach only one source, one other source. Left side one source, right side one source.
Yeah.
We have performed such kind of operations in union also, Sissy. Just recall it.
Yes, sir. We can create one branching from the source and then again perform lookup.
Yes.
And then we can join both using a union.
Yes. No, here, no question of union. Because you are not trying to merge rows.
If we want both the tables to be in one sync, we need to combine those two, right?
No. You misunderstood. Observe this. Come back to the previous example. Only one sample row I am giving you. The sample row of sales table is like this. T1 is a transaction ID. Date of transaction 2021, month 1201. Customer ID is C101. Product ID is P2 or P1. Price 50,000 and place Hyderabad. In the case of customer info table, the value is like this. C101 is Mr. Ravi. Only one row I am taking for example. Product ID P1 means that is a laptop. What finally I am expecting in the output? P1 as transaction ID, 2021 12 01 as date of transaction, customer ID C101. What is the customer name? C101 means Ravi. Product ID P1. P1 means which product that is? Laptop. And the price is as usual 50,000. I don't want to apply any discount. The place is Hyderabad. All these things are into single row. What union is doing? Union will merge rows. Got it. All of you got my expectation here. Sir, confirm me. Did you understand my task?
Yeah, here they have applied two lookups, I guess.
Yes, two lookups. So previously in union, same technique, what you followed? If I have four sources, source 1, source 2, source 3, source 4. But union is supporting only 2. At the time, what you have done? First two sources to one union, second two sources to union 2. And finally, union 1 and union 2 with other union, you are merging. Similar kind of technique you need to follow here. Come on, try to say. Think that your first one is source 1. The source 1 is our sales. For this, you will add lookup.
Lookup one.
In the lookup, you will add source 2. Source 2 is
Customer info.
customer info. Up to now, this kind of work is done or not?
Yes.
Okay. Now again, treat this lookup 1. Treat it as lookup 1. This lookup 1 as input for the next lookup. This is lookup 2. Here you just configure source 3. For the source 3, just give
Product info.
product info. Your product info. Now you can edge. And finally map into sync. Between them, if you want to drop or perform any, generate any new fields, involve derived columns. Okay. Involve derived columns or select transformation like that. In this way, by using multiple things, you can achieve the same goals. Without lookup, what is the alternative? In SQL point of view, just tell me. I don't want to apply the lookup. same kind of features I want to generate, we have to go
Join.
with joins. But why we are not going for joins means joins causes more computing power. That's why for such kind of simple key value association, you can perform with lookup. Okay. But joins are, in some cases, joins are more important, especially in the chat. Please check the chat, sir. Rajesh, I think Rajesh has a question. Rajesh, can you repeat that question? I am repeating his question. In lookup, can we pull multiple columns? If you want to pull multiple columns, that is demanded in lot many situations. If I want to pull multiple columns, if I want to associate multiple columns at a time, then I have to go for joins. Okay.
Okay.
The next transformation is joins. Because a lot of information is not available in one single table. Because the database design in OLTP systems is maintained as per the rules of normalization forms. According to the normalization forms, the main goal is avoid redundancy in the table. That's why they are maintaining all employee details into one table, his attendance details into other table, his departmental details into other table, okay, and his projects details into other table. If you go for the projects, only what are the projects available, only that information available. If you go to the departments, what departments in the organization, that is available. If you go to the attendance, at what date, what time he entered into the organization, only that information will be available. Complete employee master information, which is personal information, available into other different table. A single information is not available in, complete information is not available in one particular table. This is the technique they are following, but how these tables are interrelated is by using primary key and foreign key, the relationships will be established between the tables. Now you want to join, you want to combine, especially in warehouse, in OLTP, normalization rules will be applied. As per the normalization rules, the OLTP databases data modeling will be done. But in data warehouse, that too, for big volumes of data warehouse, denormalization rules are recommended. Opposite to the normalization. Suppose example of normalization, one of normalization, I'm not going to detail like what is form 1, what is form 2, I'm not going into that RWMS concepts, just example in OLTP, employee details into EMP table with name, ID, name, salary, gender, department name, department number. Just think it. Department details into DEPT table with columns of department number, department name, department location, and manager ID. The manager details into manager table. Just an example set. Manager ID, manager name, and manager phone number. Think that here, there are three tables, EMP, DEPT, and manager. Three tables are there. How these three tables? For now, these three are independent, but there is no relationship between them. So in the case of ID, that is a primary key. Here they make this department number as foreign key. This foreign key is referring to department number of DEPT table. But this this department number in the DEPT table, it should be primary. Again, manager ID. This is the foreign key here. This foreign key refers to manager ID of manager table. The manager ID is primary key here. Now tell me the hierarchy of your table, sir. What is the super child here, grandchild here in this entire hierarchy? Hello, sir.
Manager ID.
No, grandchild I am asking. You are saying grandparent. Employee, observe, sir. EMP is child of DEPT. DEPT is child of manager. So manager. So how you can say manager table as a parent here? This is a super parent. This is super parent because it does not have any foreign key. But department table has manager ID as a foreign key. That foreign key is referring some other parent. That parent is manager table. So here hierarchy, high level hierarchy, manager is super parent here. Its child is DEPT. Its child is employee. Now I have a query. You have loaded all the data into Synapse as 3 separate tables, but your Synapse, your analytics manager needs a query. Manager wise, for each manager, what is total salary budget? For each manager, what is total salary budget? So here you just observe this, the challenge within this task. Of course, you can apply the joins, you can query the data. You can query the data. That to subqueries, that to includes with joins that you need to apply here to achieve this query. But every time when you apply the joins, already I told you, joins causes more computing power. Generally, the time is taken on a big volume. If the time is taken on 1 hour, if the joins are involving, the time may be taken even 10 hours also. Every time you are requesting same query, every day night you need such kind of analytics means every day it is going to run for the 10 hours. That to daily the data volume is keep increasing. That's why the solution for this problem is go for denormalization. In the denormalization, suppose what I do is in my warehouse, which is Synapse, I will create a table. Suppose the table is a denorm of employees, denorm employee. Within this, I will keep all the columns: employee ID, name, salary, gender, department number, and his department name, department location, and manager ID, manager name, and manager phone. All of you understood the solution. This is called denormalization. As per normalization, all employee details into separate table, departmental details into separate table, manager details into separate table. If there is a project details into separate table. Because a single manager can head multiple departments, a single manager can handle multiple projects within a department. That's why. So this is the data model in OLTP systems, but in warehouse systems, the two for the big volumes, denormalized way we need to follow. Of a single entity, all employee related details should be kept in one single table. This is called denormalization. Whenever I have this kind of denormalization work is done, simply that you can perform a small query, select manager name, comma, sum of amount from your table. The table is a denorm underscore emp, a group by manager name. Understood? Simply for each manager ID, you will be getting your results. Now query executed only for to perform your group by operation. But query will not, the process will not struggle for joining kind of organizations of the three data sets. But only initial load, only for the initial load, you will apply join. Remaining all analytics straight away from single table you are applying that one. All of you understood about this scenario, sir? Sir, waiting for your confirmation.
Yes, sir.
So why we should why we should perform denormalization means what is your answer? This is one of the regular activity while performing transformations. What is the need?
To improve the performance.
To obviously to improve the performance, that too especially for the big volumes. For example, to achieve this answer, to achieve my required answer, observe this. A two steps query I am doing, sir. For each manager, what is the total salary budget I want? 1 minute, I will just keep on the line, sir, please. Yes, sir. What was the topic? For each manager, total salary budget. Directly you cannot achieve this one, because there is no connection between employee table and manager table. But between them, department has a relationship table. So here, from here I want manager name. From here I want a department name. Got it? So for this, what in the step one, what I do? Select manager name, comma, department number from manager table. Let's say as X, which is left, join. The right is a right side table, department as Y. On X dot department number is equal to Y dot department number. So here you have to conclude whether it is from X or Y, you have to conclude it. I'm saying that this is from a Y. Sorry, the link between manager and department is based on the manager ID. Manager ID. This is query level number 1. So here Y dot department number I'm saying. Suppose manager is Ravi, his department is 12, but what is that 12, that information? By using this department number, again I will join to these things and finally I will fetch this salary. In this way, many levels of joins, 2 levels of joins that you need to apply in the form of a subquery. One single join causes a lot of time. That too in the subqueries, if 2 joins are involving, that is going to take more time. Instead of to avoid that problem, simply the solution, denormalize data for big volumes in the warehouse. All employee related details you just keep into one single table and then start applying your analytics. In this moment, your analytics manager needs this query. After next 1 hour, he may ask you for each department, what is the total salary budget? Still, that information also available in the same table. You can simply query the data. Understood, all of you? That is the reason you have to apply joins every time. Because we are going to violate, in analytics, we are going to violate normalization rules of OLTP systems. For that, denormalization is recommended. For that, joins are important. Got it? So lookup, if for simple key value association only, you have to use lookup. For all the remaining activities, you have to use joins. But if it is employee, definitely your employee files are not single. Daily new employees are coming. Whatever the new employees, new updations happen to the employees, daily those things are coming in the format of new files. That means multiple employee files you are getting. That's why you have to apply unions. Got it. In this way, every transformation is important. No transformation is neglectable. Right? So about these 4 transformations in coming 2 sessions, we will see complete practical part of it. Okay. So tomorrow, December 31st, still we have class, sir. Okay. So if necessary, by talking with all the people, we decide the things about the January 1st. Yes, sir. Someone is going to ask me.
I have a question.
Yeah, please, sir.
Question regarding, like, do we have any stages like change data capture or slowly changing
Yes.
dimensions?
After completion of all these things, I will be explaining you about SCD. First of all,
and what about change data capture? Like, if you want to
everything.
compare the data. Okay.
First, I will go with incremental loadings. After completion of all the transformations, incremental loads. How to perform incremental loads. Okay. And after that, I will come to the SCD. In SCD, we have SCD1, SCD2, SCD3. Now today, SCD6 also available. At least we can apply like up to SCD1 and SCD2 and also SCD3. Okay. So SCD6 not yet fully matured into the ADF. At least SCD1, 2, 3 that you can. Okay. And change data captures, to maintain the change data captures, direct facility, there is no involvement of direct facility like a Snowflake kind of things. By using but indirect techniques, you can maintain change data captures. Got it? But slowly changing dimensions are completely different when compared with the change data captures. What exactly those things we will be discussing, everyone. That is into the project scenarios we will be seeing. First, let me complete all the scenarios, like not scenarios, all the transformations. Okay. Okay, all of you, let's meet tomorrow, sir. Tomorrow morning.